to do? Okay, where's concave up, where's concave down? And to change the concavity is where the second derivative is 0. Okay? So, and when we find that, we think, we're not sure though, Garrett, so don't assume that they're inflection points. Sometimes they're not. So we're just going to say we're going to find critical numbers. Now, critical numbers of what correspond to zeros of the second derivative? Critical numbers of what other function? F of x or the derivative of x? F of x. On the first derivative, they were critical numbers of the function by setting the second derivative, or excuse me, the derivative equal to 0. So if I want to do the same thing down here, it would be of the first derivative. Yeah, so I want to find the zeros of the second derivative. So I want the second derivative to be equal to 0. Do I need to rewrite that again, like I did the first derivative? Take a look at what we've got. Any factoring we can do? Does someone say factor out a x minus 4? Good, I agree with that. We got x minus 4 in both of these, don't we? So that leaves me with 4 times x minus 4 plus 2 times x minus 1. Or in other words, let's see, x minus 4 is that first factor. And then let's see, this is 4x minus 16 plus 2x minus 2. What is that? 6x minus 18. Take a look at that. If I factor out an x minus 4 from both of these, I have 4 times one more of those. That's this part right here. Plus 2 times x minus 1, which is right there. And if I multiply through, you expand this. 4 times x minus 4 is 4x minus 16. Then we have 2x minus 2. 4x and 2x is 6x. Negative 16, negative 2 is negative 18. So I could factor out 6 from this. And let's see, that would be x minus 3. Critical numbers of the first derivative will be where x is 4 and where x is 3. Now, let's go back. What do these tell us? Right here. These are possible what? Possible extrema, okay? So possible extrema. We don't know if they're max or mims, do we? We just know that they're possible extrema. Don't know which one they are. Could be either one. However, when I get down here, I have a critical number of x equals 4 or x equals 3. One of those is going to give me a little bit of trouble. Do you know which one? These give me what? In my second derivative, these are possible what? Where does concavity change? Inflection points, possible inflection points. But I got a problem. Up here I said x equals 4 is a possible extrema. And down here I'm saying it's a possible inflection point. Can it be both? And what does it look like? Take your inspires. Let's put this in the let's put this in a graph here. I always go back and put in the original. So we've got x. Put a multiplication sign. If you don't put a multiplication sign there between the x and the parenthesis, it may not read it correctly. So x minus 4. And that last quantity is raised to the third power. I'm going to change my window just a little bit. And let's see. I'm going to make this -1 to 7, scale by 1. And -30 to 5, scale by 1. -1 to 7, -30 to 5. Let me get this nice little curve there. Do we have an extrema? Okay, where do you think that is? Based on our work here, our possible extremas were at 4 and 1. Looks at possibly at 1? Okay, I'm going to put a point there. Actually, I'm going to put a couple points because I also had a value of 4. I'm going to put another point there for the 4. I don't need to put them right there. We know that. But I also have possible inflection points at 3 and 4. And so I better put another point on here because I don't need to put 2 4s on there, but we'll put that on. Okay, so this is at 1. It went down to there like we expected. This one is, what was it, 3? We'll put that 3 there. Whoops, kind of crowding my other work here. Let's see if I can grab that. I know what I better do first. Let's put the 4 in first, just to make sure that we can see it here, since we see we have a problem with that. So I'll put the 4 in. There it goes. I'll put the 3 in. And there it is. Possible inflection points. Now let's see what we have to do here. If it's a possible inflection point, then that means that on one side of that possible inflection point, the curve is concave in one direction, and after it, it's concave in, is that really a 3? Did I, it's not the same numbers I had in the other class, and I'm trying to decide where I might have made a mistake. I don't see any, do you?
Did you factor it wrong?
Did I factor it wrong? If I take a 6 out?
I think, like, up, actually, further.
Up here? If I take out an x minus 4, I have a 4 times x minus 4 and a 2 times x minus 1. I'm not quite sure. And you know what? I'm a little nervous. I want to make sure you have time for that quiz. How about if we put this away until Tuesday? Okay? I can see that it might be to our benefit, so we'll pick this back up on Tuesday.